youngkim.net, you can get the lecture PPT material as well as Wireshark Lab PDF file. You can download this one, then you can see using that zip file you can expand, then you can see those are uncompressed. And here you can see introduction, that is the first one. I will explain about Wireshark Lab assignment in this semester. We will get 5 Wireshark Lab assignment in this semester. Before midterm exam, 2 among them. And after midterm exam, we'll get 3 Wireshark Lab assignment. And first one is introduction. You can see this compressed file, and that will be uncompressed. Then you can see the different files. Actually, there will be 6 file names. Among them, we'll get these 5. And UDP, that is just for practice. Thus, 5 assignments are assigned in this semester. First one will be introduction, and Wireshark introduction version number 70. That is the file name for the first assignment. And the second one is HTTP. The others are exactly the same with others, and only this one you can differentiate from others. Third one is DNS. Fourth one is TCP, and the UDP is in the transport layer also, but that is assigned as practice. And the final one will be IP. Okay, to get the Wireshark program, I'll show you later. Anyhow, wireshark.org, that is the URL for that, and you can download and install. After downloading, you can install. And that Wireshark is a kind of package sniffer program, and that is the most popular network protocol analyzer. And during your installation, after downloading, you can see this MP cap. Probably that is a network packet capture. That is Windows packet sniffing driver and library. And that is owned by this insecure.com. They developed the copyright by this one, and you can see the Nmap project and the helper program for admin only mode. Those will be shown during your installation. Even after installation, sometimes you can see to start the capturing. This one is asking about this user account control. Application device wants to get the device change, then you should choose this OKYS. That's it. And I will explain. To download Wireshark Packet Analyzer software, please use this URL, wireshark.org. After that, you can get this web page, and here you can simply click here for downloading, and here you can choose depending upon your operating system. I'll choose this one, and that will be downloaded here. After successful installation of Wireshark, you can see this desktop icon. If you click this one, we can initiate that Wireshark operation. Okay, simply you click many times, around 10 times, to make it enabled. Okay, from this contents, Wireshark introduction, that is the first one. Among these 6, actually 5 will be assigned, as I explained already. This one is the first one. Let's look at this one first. Okay, here, this one is the first Wireshark Lab assignment. Here, try to understand this one. And we are using this one, packet sniffer. Wireshark is that. And that is composed of this packet analyzer and the packet capture. And after understanding of these contents, listing of captured packets, and each individual packet here online is individual packet, and if I'm clicking this one, then that is the expanded contents about the contents of each packet. This one is the binary format of these contents, exactly same, but you cannot understand with this binary format, and just for reference, and this one is more readable about each packet. And try to understand, mainly you need to understand fully. Then after learning until here and here, this is the assignment. What to hand in? You should submit 1, 2, 3, 4. That is the 4 questions, and you are simply submitting the answers for each one, and that is the first assignment. That's it. From this youngkim.net, you can see this web page, and here if you are clicking this one, you can come to this bulletin board. If you are clicking this home URL, then you can come here. Let's look at this supplementary lecture web page. Here, interactive animation. In this menu, we can see some contents about this chapter number 1. This is called interactive animations. First one is about transmission versus propagation delay applet, and the second one is about queuing and loss applet. Third one is message segmentation. Let's look at this one first. Okay, here you can read this one. This one is about transmission versus propagation delay. With this animation effect, we can understand better. We can choose some options here about this length, about the speed, transmission rate, and the packet size from here to here. And let's choose 1 KB packet size, and rate is around 100 megabps speed, and the length is around 10 kilometer. And let's start. Then you can see that packet is being transmitted through this communication link, and we can enlarge the length in this estimation. Then we can see again. Then you can see that is being propagated, transmitted. That is from here to here. That is propagation delay time. The speed is near to the speed of the light, because this electrical medium that is different from the free vacuum space. There's the light speed that is not here. Okay, you can understand the propagation delay, and also depending upon the transmission rate, the speed will be changed. And yeah, we are learning due to the PowerPoint slide. This one is explaining about the propagation delay. Okay, let's move to the next. And this one is about the queuing and loss. Okay, let's assume this one is one intermediate router, and our packet goes through these intermediate routers and many routers. But to understand clearly, we are focusing only one interactive router. And here, this one is showing some memory, and that is a finite size. And depending upon the buffer size, the overflow is happening. And let's look at this initial default value. Let's start. Then this is emission rate. 500 packets per second that is being arrived to this router and this queue, and that is going out. This is outgoing transmission link, and it is going out through this router, and that speed is 2 times higher than this. There is no waiting here, and it is immediately going out. But if we are okay, let's use the same value here, but this one is slower speed, and let's start again. Then you can see this one is so slow. There's if the time is elapsed, the queue will be used, and after a certain amount of time, this buffer will be occupied fully. Then the drop of the packet will be happening. And one of your questions in the homework assignment, in the last chapter, in the end of each chapter, you are assigned to some homework assignment, and one question is asking about that. When that first dropping is happening like this, then you should observe this one, and you should observe several times, and that may be different because that incoming rate is random. That means stochastically or statistically that is randomly arriving. Because whenever you are simulating or emulating this one, that dropping time, the first dropping time, then may be changed. Okay, you can start later again. Okay, let's move to the next. Okay, another one is about the message segmentation. If we are sending big file that is not being sent to the same size, it will be sliced into smaller pieces. That is called each small PC, that is called the packet. And here you can see and understand better about that. And as an assignment, I will ask you to lead this one, but you don't need to submit, just to try, understand fully. That is enough. Okay, another contents. Let's look at this menu. This one is about the video notes. Let's click this one. Then you can see some video clips are here. First one about chapter 1, propagation delay and transmission delay. That is explaining about that, and that is the video.
Hi everyone, this is
by
Keith Ross.
All of the
and
author.
in this video note, we are going to talk.
And the next one is about trace route. What is trace route? That will be explained in this demonstration.
Okay.
Also, this professor is Mr. Cross, one of the author of this textbook. You can watch this video, then you can understand better.
Through the internet from my house here to a server.
Let's start from here. In this start button, you can see some execution button here. Then simply you can put in CMD, that means command. Then command window will be shown here. Then here trace RT. We are learning about trace route. Instead of that trace route, trace RT will be used here. After that, some domain name like the google.com. Okay, then you can see this one is iterating this time 3 times and some IP address. This is the first IP address. That means first router, gateway router. After that, the other following intermediate routers until to arrive final server. And that server is google.com app server. We are tracing. With this trace RT, we can trace that the intermediate routers. And how long does it take? 3 times. This one is measuring, and this one is showing the intermediate routers IP address. If you want to interrupt, then simply Control C, then you can interrupt. Let's try other trace RT. This is near from my computer, thus it will take less time. That means less intermediate routers will be used. This is the first router called gateway router. And okay, and this one is the IP address of the server. The others are IP address of the routers, intermediate routers. First router and second one, third one. Finally, this one is the server of this domain name. That web page for that. That is the web server IP address for that. We can trace in this way. You can try others. Okay, let's continue our discussion about the chapter number 1. We are in this number 49 slide. The number of the slide is 49. This one is explaining about that previous command, trace root. Actually, we use the trace RT instead of trace root, but in the router we can use some command that is using this trace ROUTE instead of trace RT. Depending upon that equipment, we can use different command name or program name. Here, trace root, and actually we use trace RT as I mentioned. Okay, let's follow this one. After enlarging this one, real internet delays and loops. What do real internet delay and loss look like? We can use this program or command. This one is providing delay measurement from source to router or end-to-end internet path towards destination for all I from first router, that is 1. After that, following numbers 1, 2, 3, 4 until to arrive successfully to the final destination, that is the web server, as we observed already. Send 3 packets. We measured 3 times because of these 3 time packet measurement. That will reach router first, if that is iterating from the beginning, 1, 2, 3, 4 like that. 1 pass towards destination. This one is gateway router, first one, second one, third one, like that. Router intermediate router I will return packets to sender, and the sender times, this one is measuring the time interval between transmission and reply. This one is measuring the time between the departing time and arriving time, then the intermediate difference, that is the round trip delay time, like this. 3 times, that is 3 times probing. 3 probes here, and that is related to the 3 measurement. Okay, this one is another example, but you do more intermediate routers. Trace root, or we can use trace RT. In Macintosh, that is using this trace root command instead of trace RT, depending upon their equipment, or Unix or Linux, then may use this one. This one is the final destination web server. This is located in France, thus it may cross the transoceanic link, thus it may take more time. Here, from this university and internally in the campus, it will not take much time, but after certain campus, it is going out to outside, and it is going to the France, and it is issued, transmitted across the transoceanic link, and it will take more time, like this, more time. Finally, that will arrive, but before that, you can see some asterisk that it is not properly provided. It is not responding properly. That means the measurement that may be lost, or intermediate router is not replying because of the security reason. Then this one is not showing the proper numeric number, and instead of that is ambiguous, this asterisk that will be shown there. Let's look at this packet loss. As we learned already, also we observe the animation. This Q, also known as buffer, preceding link in buffer has finite capacity, that is not infinite. That means that has the limited capacity in terms of the memory size. There's a packet arriving to full Q, then that will be dropped. Thus that is called lost. Lost packet may be retransmitted by previous node, by source and system, or not at all, depending upon the protocol. Thus our protocol should deal with that loss and to recovery from that loss. Throughput is a kind of performance, and that is the this one is the unit for that. Rate, bits per second, at which bits transferred between sender and receiver. We can divide into two categories. One is instantaneous throughput, another one is averaged throughput. This one is, as the name is self-explaining, rate at given point in time. The throughput will be called instantaneous throughput. If we are measuring the average or mean value of that throughput, then that is called average throughput. That means during longer period of time. Here, from here to here, you can simply think the analogous example. Think about some water pipe instead of a bit pipe. Then that may be understood better. Server send the bit into pipe. Thus this one is called bit pipe. Okay, let's assume we are using two links as intermediate links, 1, 2. Then which one is dominating? What is the average end-to-end throughput? Usually this narrow one that is dominating the whole throughput. Thus here the whole throughput will be RS. Here, if this one is here, then that will dominate the whole throughput. The whole throughput will be RC. This is called bottleneck link. That means bottleneck link is dominating the whole throughput. Link 1 end-to-end path that constrains end-to-end throughput. Think about this case. More links, then which one will dominate the whole throughput? In this equation, we can get the value for that minimum value among these. Among single communication link, here RS first, then this R will be shared evenly, and this one is, let's assume this one is 10 links, then this one is simply R over 10. Then among three components, RS, R over 10 or RC, which one is dominating? The minimum value, because that is bottleneck, that is dominating the whole end-to-end throughput. If we are considering our real internet service provider here, usually then this one will be usually sufficient enough. Then usually that edge link here, or this one, that will dominate it, and that will be the bottleneck link. Okay, let's move to other topic here. Let's start from this subchapter 1.5, protocol layers, service models. Okay, this is about the protocol layers. Think about the networks. Networks are very complicated and complex. With so many pieces like hosts, routers, link of various media, applications, and protocols, hardware and software. Question is there any hope of organizing structure of network, or at least our discussion of networks? To simplify that, we need some concept. This is the organization of air travel as an analogous example to understand better about computer networking protocol layers. When we are using this air travel or using airline, then we need to purchase ticket first. After that, baggage check and gates we are using, and runway takeoff after that, and the airplane will be routed. That is routing several places if we are dropping by several places. And sometimes that may use direct line. This is called airplane routing. That will be arrived there, and the airplane runway landing and gateway here unloading, and the baggages will be claimed, and finally will arrive at the airport, and will go to the final destination in our whole journey. We can think each step like this. After making modular design, we can make each one as a module. Modular design is easy to handle, and in the departure airport and arrival airport, intermediate air traffic control center on the routing, and here we can think these layers. Each one can be a layer, and this one is implementing a service by its own internal layer action, and also that is relying upon services provided by layer below. And also here, this one is providing service to the upper layer. Why we need the layering? We can deal with complex systems with this scheme. Explicit structure allows identification, relationship of complex systems pieces. Layered reference model for discussion we can use for simplification and for better understanding. Also, with this layering, we can modularize. Thus, modularization eases maintenance, even updating of system. The change of implementation of layer service transparent to the rest of system. That is the advantage of this layered architecture. For example, change in gate procedure doesn't affect rest of other system. Thus, layering is useful instead of harmful. Thus, Internet Protocol stack was considered with the implementation of layering architecture. Thus, the layered architecture here, we can divide into several pieces, several modules. And the first one here, on the top side, that is application layer. This one is supporting network applications, for example, FTP, SMTP, HTTP, we learn later, file transfer protocol, simple mail transfer protocol, hypertext transfer protocol, we learn later anyhow. Those are protocols related to this application layer. And if we are looking at the other layer, the other module, then this one is transport layer. And this one is process data transfer. That is the main purpose of this layer. And that example is TCP protocol and the UDP protocol we are using every day. And the middle one, among 5 layers, this is third layer, Premier, that is in the middle. This one is mainly for routing of datagrams from source to destination. Example is IP protocol and the routing protocols we learn later in network layer. And this one is from bottom, that is second layer. Actually, we are starting from this to count that number of layers. First one, second one, like that. This one is the second layer, and this link layer is mainly to do data transfer between neighboring network elements. And this one can be used for example of this Ethernet 8.11 or 8. Some 11 ABG, that Wi-Fi, or 802.12345. That is the sequence number of the standard number. Actually, Ethernet is 8.3, token bus is 8.4, token link is 802.5. In the sequence, we are providing the standardized number, and Wi-Fi is 8.11, and also in that Wi-Fi there are several versions, there's A, B, G, and so on. The first one on the bottom, it is the number is starting from the bottom, thus this one is the first layer. This one is about bits on the wire, how to transmit. And for radio, the air can be used freely, and Ethernet cable or coaxial cable, as we observed already in the previous videos, even fiber optics. Okay, let's move to the next. Among many standard bodies, this is Organization of International Standard Organization. This organization try to do make standards as an open system interconnection reference model that is 7 layers like this. Thus this is 7-layered architecture. This is OSI reference model. Here 2 more layers are inserted here between this application layer and transport layer. Presentation layer, that is allowing applications to interpret meaning of data, for example encryption, compression, and machine specific conventions for presentation. Thus this name is presentation layer. And the session layer, that is mainly for session, for example synchronization, checkpointing, recovery of data exchange. But in our TCP IP model, we are using 5 layers. After this we will look at, thus these 2 will be implemented in the application layer. Thus this one is merged into single layer like this. Internet step, missing these 2 layers, and these services, if needed, must be implemented in application layer like this. Okay, let's look at then 5 layers. TCP IP, that the protocol layers are composed of 5 layers like this. Thus let's refer to these 5 layers instead of 7 layers. Okay, let's assume this is the source computer, and this is destination computer. And from this source, for example, your PC is sending some data to their final destination, then it is going through. It is traveling like this. It is coming down into that message, but the header in each layer, that header like an envelope of the mail message that is added here. This HT means header in the transport layer. Also, that will be come down for transmission, transporting to other final destination. And this one is considered as a data, and this one is attached as a new envelope. There's network layer header. And also this one is considered as data, and another envelope that will be used here, that is link layer header. And here no header, just simply that is electrically sending like this. It is going through like this, and finally that will be arrived there, and in reverse way that will be peeled off. The header will be used for processing. This is the protocol. The protocols are implemented here, mainly in the header, and finally after peeling off, and that will be used for protocol processing. Each header will be used, and finally that will be arrived. The main message will be arrived to the final destination. Let's look at network security issue. And even though this one is mainly discussed in other chapter, for example, in this 7th edition, chapter 8 is mainly explain about this security issue, but this one is briefly introducing about this security, because this is important also in terms of the overall picture of the whole computer network. Network security. This is a field of network security. How bad guys can attack computer networks. This one is dealing to that, and how we can defend networks against that attacks, and how to design architectures that are immune to that attacks. Actually, internet, when that was originally designed and developed, that was not considered at all. Thus, internet not originally designed with security in mind. Thus, the original vision was simply a group of mutually trusting users, mainly engineers. They are trying to develop this simple networking scheme. And this one is they are attached to a transparent network to simply send the file and to simply send the mail and so on. Internet protocol designers playing catch up, and later many different kinds of business are depending upon this internet structure, and bad guys are trying to utilize this one. The security that is considered, and one of the most important topics we should handle. Security consideration in all layers. Bad guys. These guys are putting malware into hosts via internet. Mal means that is bad thing, bad stuff into hosts via internet. Thus, malware can get in host from virus or worm. This virus means self-replicating infection by receiving and executing object, for example, email attachment. And worm, that is a little bit different from this, and that is self-replicating infection by passively receiving object that gets itself executed. And also we can experience there are so many different malware and spyware. This one is the spyware malware. Can record keystrokes, websites visited, and uploaded information to collection site. And impacted host can be enrolled in botnet, and that can be used as a zombie computers and to attack in this DDoS attack mode. For example, this is the DDoS, and DDoS means another D means distributed denial of service. Thus DDoS means distributed denial of service. Attackers make resources or server or bandwidth, and that will be unavailable to legitimate traffic by overwhelming of resources with bogus traffic. Those are fake traffic, and that is occupied by these bogus traffic, and legitimate traffic is not possible because of that. Bogus traffic. This is called DDoS attack. Thus, during that DDoS attack, the target will be selected, and that will be used for zombie. The others will be used the zombie computer, and this one is controlling that zombie computers, and they are providing to that the targeted computer. This is server, and this targeted server cannot respond to other normal and legitimate traffic because of this bogus traffic. Those are, in other words, those are compromised hosts. Okay, bad guys can sniff packets. We are using this packet sniffer, but to learn computer network in more detail for good goal object. But this packet sniffing, that is sometimes that may be used for dangerous purpose. Let's look at this one. Broadcast media, usually Ethernet and shared Ethernet and wireless Wi-Fi, they are using broadcasting scheme, and this promiscuous network interface, that means all kinds of traffic can be detected and read and recorded, even passwords that is passing by. And the Wireshark software, this one is a kind of packet sniffing, but to learn protocol in more detail for good purpose. But if that is being used for bad purpose, then that by the bad guys, then that will be so dangerous. While Wireshark software used for end of chapter labs, we will do 5 labs. First one is introduction, as I introduced early in this lecture. This is a pre-packet sniffer. Also, bad guys can use fake addresses. This one is inserting and modifying with the wrong source address. This is called IP spoofing. IP spoofing means send packet with the first source address. This server will respond to that address, wrong address. And more security is being discussed in the chapter 8. That is explain about all security issues there. Okay, final chapter is about history. We can omit this one, but there are some important concept I will explain. Internet history. Let's look at the history of internet. Usually that is being started around the 1990s, 1960s actually. During this time, 1 decade, early packet switching principles. Kleinrock, this is the professor in the University of California and Los Angeles. Queuing theory, that theory is good for packet analysis in terms of delay. And as we learned, the queuing delay. Queuing theory shows effectiveness of packet switching. And after that, ARPANET, that is being considered to design better architecture because the United States, America is competing with the Russia, USSR, and they are competing in terms of military power, and communication is so important. And one of the projects is to derive new architecture. That is a packet architecture, packet network, packet communication scheme. And in 1972, ARPANET, first ARPANET, and this is showing UC Santa Barbara, UCLA, and the Stanford Research Institute, and Utah University. They are interconnected with the mainframe computer and with some network control program, and that is a kind of internet software and internet architecture. It is being started with that simple architecture. After that, it is being growing in terms of architecture, and in terms of the number of computers growing rapidly. After that, in another decade, next decade, internetworking, new and proprietary networks. After that, AlohaNet in Hawaii, satellite network, and in Pinton Surfer and Popcorn, they designed some architecture for interconnecting networks, and Ethernet was developed by Xerox PARC and standardized after that. And after that, another proprietary architecture by the Digital, DECnet, and by IBM System Network Architecture, and so on. And after that, new technologies are shown, introduced, and some technologies are gone away. In their competition, they couldn't survive. Finally, anyhow, Ethernet, that technology, that is one of the technology, still that is being survived. After that, still continues that the nodes in the ARPANET is growing. When the Pinton Surfer and Popcorn, they are designing this interconnecting, internetworking principles, minimalism they considered, and autonomy. There's no internal changes required to interconnect networks, and the best effort service model instead of the perfect service model, best effort. Thus, there may be some error. Thus, the network should take care of that error. The protocol should take care of that error handling. And the stateless routers, the state is not saved. Decentralized control instead of the centralized control, and define today's internet architecture. They defined today's internet architecture. And after that, in the next decade, new protocols of proliferation of networks. TCP was introduced, and deployment that is deployed in the real world, and SMTP, DNS, FTP, TCP congestion control we learn anyhow later, and those are developed and introduced. And during that time, new national networks, they were introduced like Minitel in France, but they were very successful at the time, but later they were failed in the long-term utilization and long-term application. Finally, internet, that technology with the Ethernet and so on, they are successful in the real world. And still many hosts are connected, and it is the network, internet is growing in terms of the number of hosts. And after that, And as you know, the commercialization of the internet, that was not expected at all by the engineers, but that is being used for commercialization, for business. There's security issues is becoming more serious, and it is emerged a lot. The security issue is emerged. ARPANET decommissioned, and the National Science Foundation, and that is providing NSFNet, and also that is decommissioned after that. And after that, web hypertext, that concept is introduced, and by the Tim Berners-Lee. And in late 1990s, commercialization of the web and internet era, and internet business, strong internet business, and large global internet business companies, they are introduced in the world. More key applications: instant messaging, P2P file sharing, and the network security to forefront, and many a lot of hosts are attached in the network. It is still growing so rapidly. And also backbone links, the connection links, that speed was increased so rapidly also. Also the memory size increased rapidly in terms of computer architecture. From the period of between 2005 and the present, there are so many equipments, computers, and devices, later Internet of Things. Those are all attached to the internet. And aggressive deployment of broadband access. Thus, as you know, fifth generation LTE, fifth generation, fourth generation, those new communication technology and the standards are being used. Increasing uniquity of high-speed wireless access, ubiquitous high-speed wireless access, and emergence of online social networks, for example, Facebook. So many users, customers in the world, and the service providers, Google, Microsoft, and the cloud service, also big data, and the newly introduced new technologies are so popular recently. And e-commerce, and major e-commerce companies are introduced in the world, and they are using new architecture, for example, by Amazon, elastic cloud computing. And we just overview. We just reviewed internet overview and fast protocol. Simply we learned about that. And network edge path, core path, access networks, and we learned about packet switching briefly, and the circuit switching. It's just to differentiate briefly. Internet structure, and the performance issue, we learned about that, loss, delay, throughput, and the layered architecture and the service model. And even though we learned briefly about the security, they are introduced, and history. And we just got some feeling about the networking, but we need more information. Thus we are studying from the chapter 2, thus from the application layer, more in detail. And this one is additional slides about the Wireshark, and you can understand better due to your Wireshark assignment. And this one is Wireshark, and this, as I mentioned already, this one is composed of packet analyzer and the packet capture. Instead of this, we are using this packet MP cap, that is newly introduced. We are using that. And this is OS, operating system. In that operating system, this transport layer and that link layer, those are related to this one. And application layer is using this one. And this one is providing some copy of all Ethernet traffic, packet, and frames sent and received, and that will be captured. And we are analyzing using this packet analyzer. This one is the main functionality of the Wireshark, and you can understand better through your Wireshark lab assignment.